Hi and welcome to a very exciting tutorial, this time with a neat little game, which you all know, which is Tic Tac Toe. And you can thank the great people who commented under the last video and shared their thoughts on what kind of tutorials they want to see. And here it is. We're going to do Multipeer Connectivity Framework today. We're going to do this Tic Tac Toe game, which is a multiplayer game. So what you can see right now is my development iPod on the right side, which is a physical device which I have connected using an app called Reflector, so that you're able to see what I'm doing on the screen. And on the left side, I have got my simulator. So first thing we're going to do is hitting the connect button, and there you see the dev pod. When I click this button, then you can see that I have to accept the invitation from the iPhone simulator. So I accept. And you see we're connected, and also here we can see connected. So let's press done, and now I can play with myself actually, which is kind of boring, but you will find someone to play with. So let's just start. You see, I press a button here, and then I can press on my the button on my iPod. So now it's my turn here again. So I want to win. I'm X, so I'm going to win here. And let's say I don't see that there is a possible winning chance for X, so let me press there, and then here I'm going to win. So you see, we can see here Tic Tac Toe, the winner is X. I click OK, and I press OK on the iPod, and you can also, once you start playing, you can also decide, oh, I want to start a new game, and then DevPod has started a new game, will appear. So that's what we are going to do. And again, thank you for that many great tutorial ideas, which you all have commented on under the last video. So let me get started with a little explanation on the Multipeer Connectivity Framework itself. So when we have a look at one of the slides that were presented by Apple at last year's WWDC, then we can see what it actually does. It is not the Multipeer Connectivity Framework, which we are using to create this multiplayer experience, cannot be used to communicate between the internet. It is used for local networks that can be established between Wi-Fi and Bluetooth. So whatever you think, or when you want to create a multiplayer game over the internet, this is not the right framework to use. So every time, only when you want to create local networking to enable people nearby to communicate with one another, then this Multipeer Connectivity Framework is the right way to go. And there are some awesome apps built with this Multipeer Connectivity Framework. I don't know, maybe you're familiar with Fire Chat, which enables you to chat with people nearby. And this is really an app worth looking into. And what we're going to explore today is that Apple has made it really simple to connect two devices to connect two devices. So the first step in establishing this connection you have already seen. So we click on the connect button, and we have, as a device, we must advertise ourselves in order to let the other device see the, let's say now we're advertising the simulator, and if I click connect on the iPod, then I can see the simulator here and the DevPod here, and they are already connected. So, but to make this possible, they must advertise themselves. We're going to do that and explore that in great detail. And also we need this neat little view controller, which allows us to connect to other devices. But the nice thing is that Apple already provides us with a view controller that does exactly that. So, and then there are different states. So there is a connecting, there is a disconnected, then there's also a connected state, for the two for the two devices. So basically, the moment you have started, the moment you are connected with one another, you have successfully paired, and you can share data between all the devices that are connected within the same locally set up network. And we're going to explore some nice classes like the MC Peer ID, the MC Session class, the Advertiser Assistant, and also the Browser View Controller, which you're going to see in a minute. And once you have paired both devices or more devices successfully, you can send data objects, you can send files, and basically you could create your own airdrop if you want between your own apps. Or between your own app, both people would have to launch the app in order to make it possible to send data between those two apps and two devices. But you could also, as you can see here, create a chat application using the Multipeer Connectivity Framework, and also you can do nice games like we are doing here. Like this Tic Tac Toe game. So let's get started. Let me just get rid of the reflector. And let's get started using the first time using Xcode in its final version. So there won't be any big code changes anymore. And we will start by creating a single view application, calling it Tic Tac Toe. Hit next and create it on the desktop. We'll make this a little bigger here. All right. So first of all, there are some nice little things here introduced with this final version of Xcode, like this launch screen zip file. And as you can see, we also have now all the iPhones that are available in our simulator. So the iPhone 5S, the 6 Plus, and also the 6. But we are going to explore the possibilities of the size classes regarding new iPhone sizes in another tutorial. So again, we will first deactivate auto layout and disable the size classes and just focus on the 5S screen size. And therefore, I have also created some nice assets like the field that we can play on, and the O and the X. So I'm just going to drag these three files to our project, and there they are. They're an add to X resolution, and well, for the iPhone 6 Plus, there seems to be a 3X version. So to all the designers, there's going to be a little change here, but so far so good. In order to create our user interface, you see it's quite simple. We just have a navigation controller here, and we have this this field for our game here. So everything we need to do in the storyboard is actually to select our first view controller, hit editor, and embed in navigation controller, and there we go. There's our navigation controller. And let's start by adding some bar button items to it, which is on the left side, the connect button, and on the right side, we have the new game button. All right, and now we will just insert another image view in order to store our field for the game, and I will just resize it so that it fits beneath the navigation bar, and then let's click on the attributes inspector and select the field, and then you could actually shrink it, or let's say aspect fit, and then just shrink it a little, just as you like. You could also design your own field for the game, or you could also use some UI views and draw the lines yourself, but I thought keep it simple, and let's just use an image here. And also for the other images, for the X and the O in the game, we're using image views, and let me just have a look. They're 5550 pixels in size, so let's create one of these image views and place it, let's say, right here. And let's select the X for now. And there we go. And then we will copy this and just paste it a few times. All right. There we go. And one more time. Cool. Now we have our field for our game. We have the possibility to tab for both players. Now, what we want to do to think ahead when we later have to identify which field has been tabbed. We're going to use the tags of each field. So this is going to be tagged with 1. This is going to be tagged with, it's going to be tagged with 0. This is going to be tagged with 1, 2. Let me just write this now. 3, 4, 5, 6, 7, and 8. And we're going to use those tags later to identify the field that has been tabbed. So for now, I think that our user interface is complete, actually. So we can get started and thinking about the logic of our game. So these areas here where we actually tab. They can have 2 states, actually. They can be player X, O, or they can be player O, or whatever you want to call it, circle or X. So we could create our own image view that stores some useful information for us, like the player, has it been activated already, the field, and we can create a function that sets the player for us. So let's do that by creating our own image view subclass. So we'll just click on the view controller, hit Command N on the keyboard, and let's create a Cocoa Touch class, which we will call Tic Tac Toe, so TTT image view, and it's going to be a subclass of UI image view. And click on next, and let's just create that. And let's get rid of the sample code here, and just give this 2 properties. Let's say first a player, which is a string, and also optional because it can be nil. And also let's give this another property, which is activated, which is going to be a bool, which is not an optional, and because we directly initialize it with false. And we will also create a set player function, which receives a player actually, and as a parameter, which is a string, has no return value. And now what we do is we check if the, first of all, we set the current player. So self.player equals a player. We could also have, leave the self out here. We receive the player, which is currently playing, which has tapped the on the image view. Then we set this image view to identify it later that this is player X. Let's say it's X, and now we check if the field was not already activated. So if activated equals false, so it's not activated, then what are we going to do? We will check if player is equal to X. Then we will just say self.image equals UIImage named X. So I have just created these images so that we have an X here and an O here. And so we can very easily initialize our image views with an image. So if it's not X, it must be O or circle or whatever. So let's say self-image equals UIImage named, and this time O. And also what we have to do is we want to activate this field, so activated, is now true. By doing that, what we achieve is that once you activated the field and a symbol X or a circle is visible, you can't change it anymore. So this is already great. So let's go back to our main storyboard and select every image view which at the moment has which are filled with X's, and let's then select our new image view class as the custom class for all of these image views. So let's select TTT image view for that, and now we're good to go. Now that we have completed the user interface, let's dive into the Multipeer Connectivity Framework stuff. Therefore, we are going to create a nice little helper class, which we will call MPC Handler, which gives us the ability to work with the Multipeer Connectivity Framework really, really easy. So I'm going to select the TTT image view, hit Command N on the keyboard, and let's create a Cocoa Touch class, which will be called MPC Handler. And it's going to be a subclass of NSObject. And since the Multipeer Connectivity Framework is not imported by default, we have to import the Multipeer Connectivity Framework ourselves. Multipeer Connectivity. All right. And we will start by creating all the necessary properties that we are going to need. So the first property is going to be the peer ID. The peer ID, which is the peer ID, is the ID of every device connected in your local network. So next one is the session itself. So the session of this of our game, if you want to call it like this. So every game is a session as long as you are connected with the other devices. You are in a session, and as soon as you're disconnected, the session is over. So we have to create this MC session. What else? We're going to need this nice view controller, which is called browser. So let's create a browser, which is an MC browser view controller. And we're also going to create an advertiser, which I already explained is necessary because you need to advertise your device so that it's visible to the other devices. And this is just called, and we're going to use the MC Advertiser Assistant. And we can define this as nil, as optional, and assign nil at this time. So let's create some functions. We're going to need a bunch of functions actually to handle all the necessary logic that we are going to need for our game. So let's create a function called setup peer with display name, and we're going to get a parameter called display name, which is a string. This is the first one. Let's also create a function called setup session. What else? We're going to need a function called setup browser. What else? We are going to need a function that will advertise us. Let's call it advertise self. Advertise. Give this a bool so that we can say if we want to advertise or not. So you could also implement a little switch control here. So what have we got here? There's no function. There's a func. So func. And I think that's all there is. But what we should not forget is, but we're going to implement that later, is that we have to use the session delegate, the MC session delegate later, to see and to listen for different events like the session did change state, or the session did receive data, or the session did start receiving resources, and so on. So let's not overdoing things. Let's focus on the functions we already have, and let's start with initializing the different properties that we already created. We are starting with the peer ID, which we are going to initialize with the MC peer ID initializer and a display name, which we get here as a parameter. So let's use the display name, and that's all there is to this setup here with display name function. And now let's create the session, which we will initialize using the MC session initializer, and we're going to initialize it with the peer ID that we have already created, or that we have as a property, and we're initializing it with the setup peer with display name function. And also we are going to assign the delegate to the session, which is self, or is going to be self, which will result in an error right now. But let's first complete those two functions before we adopt the MC session delegate protocol. And let's initialize the browser, saying MC browser view controller with service type and session. So we're going to call our service just my-game, and the session is our session, which we have defined as a property here. And now let's finish the last function, which is our advertise function, by asking if we want to advertise. And if we want to, then let's say advertiser equals MC advertiser assistant. And there is a service type, which is again my game. A discovery info, which we do not need, so let's set it to nil, and a session that we already created. And then after we have initialized the advertiser, we have to start it. And since this is an optional, we will unwrap it and say start. So if we don't want to advertise, so we actually want to deactivate it, I guess, let's use the advertiser, stop it, and set it to nil. All right. So now, as you can see, we have this error here saying that, well, let's read it, does not conform to protocol MC session delegate. So let's get rid of that error by adopting this protocol, MC session delegate. But then we will get some other errors because we need to implement all the required protocol methods. So the first one is the session did change state. So let's search for this. Session did change state. So let's then add the session session did receive data. That's maybe a good progression for this for these functions. So session did receive resources. This is another required protocol method. And also let's add did finish, did receive, did start receiving. Okay. So, and then last one is session did receive stream. And I think that should be it. Yeah, right. Okay, so as soon as we will start with the session did change state method. So we get some interesting information here. We have a peer ID and we have a state. So what we want to do now is taking this information and preparing it to use it later when we really start the connection with the other device, or when we transfer our game data. So when we press on one of the fields that we know where we pressed, and therefore we are going to create something you might be familiar with. We are going to use notifications, not the visible notifications that you can see in the notification center and in the Today screen on your iPhone, but these notifications allow us to send within our app notifications to different classes. So what we want to create first is a user info object, which will store a dictionary, which we create by using these brackets here. And this dictionary will have two key value pairs. So the first one is the peer ID, which stores the peer ID. And the other key value pair is going to be the state, which is, state. All right, now that we have, and let me not forget, this is an enumeration, this MC session states, and we are going to need the raw data. So we're going to convert it to raw so that we store an integer value here. You will see later why this was a pretty good idea to convert this to raw. And now, since the data must be, or this notification cannot be processed in the background because we need it when we need it on the main thread. We need to use a dispatch after block, or dispatch after, not dispatch after. We need to dispatch asynchronously block in order to perform this on this next operation directly on the main thread. So we say dispatch get main queue, and here is our code block or our closure. And what we are going to do is we are taking the NS notification center and its default center, and we want to post a notification with name. This is the wrong function. We want to post a notification with the name object and user info. So the name is going to be MPC underscore did change state notification. And the object is going to be nil. And user info, as you can see there, is it is expecting a dictionary, and we're inserting our user info dictionary right here. And that's all there is. The next thing we're going to do is pretty similar to this one. Within the did receive data function, and what we do is we create again a user info object, which again stores a dictionary with two key value pairs, but this time we are using the data that we are receiving, so data, and we're also storing the peer ID. Again, so peer ID, and storing the peer ID. And again, we will just copy, let me just make this lowercase here, did change state notification, and let me just copy this dispatch block, paste it here, and this time we can just reuse that code completely as it is. We just have to change the name of the notification, which is not did change state notification, it is did receive data notification. All right. So now that we have implemented those two methods, we can actually forget about all the others, because we are not going to receive resources, and we're not going to receive a stream, a data stream or input stream. But we need to implement them, because when we leave one out, we get an error because all of them are required. Okay, now that we have our MPC handler class, we have to do something with it. And we're going to use the app delegate, which is quite useful for that purpose. And we will just create an object of the MPC handler by creating a property, MPC handler, and this is going to be initialized with MPC handler. And what this does is it just saves us the need for a singleton for a class that implements a singleton pattern, so that we can also always use the same MPC handler. So now that we have completed all these steps, it's time to actually work with our user interface. So we are going to we're going back to our main storyboard, and let's see what we can do. We have to be able to access all of these fields. So what we could do by first bringing up the assistant editor, what we could do is actually creating outlets for every single one of those fields. But that would be a pain in the ass working with that kind of stuff. So what we are going to do is we're going to create an outlet collection by control dragging this to the code window. We're selecting not an outlet, we're selecting the outlet collection. And we're giving this the name fields. And say connect. And what it does is just awesome. You get an array of TTT image views, and we can now just connect each and every of these image views to this outlet collection, and can later access them as normal arrays. And that's pretty cool and saves us a lot of code. So I will just connect all of those image views to this single outlet collection. So this is actually the only outlet that we are going to need. We are later going to create the actions that are necessary. But let's first set up our game field by creating a proper function for that. So let's create a function here. Let's say directly above the did receive memory warning, and let's say setup game logic. This has no parameters, and what we do is pretty simple. We're just going to create a for loop with an index in the range of 0 to the fields.count -1. So we're iterating through the whole outlet collection here, and what we do is we will add a gesture recognizer to all of those image views, so that we are able to touch on them, because they are not buttons. These are simply image views, which have no user interaction functionality by default. So let's create a gesture recognizer, which is a UI. We can leave that out. UI tab gesture recognizer. The target is going to be self. And the selector is, let's say, field tabbed, with a colon to indicate that there is going to be a parameter or some parameters. So, and now let's customize this gesture recognizer by telling it how many tabs are required to fire an event, which is just one. And now we can just say fields, access the fields like an array, add the index, and add the gesture recognizer to each and every image view that we can see here on our field. So gesture recognizer. All right, what we have forgotten earlier was to activate the user interaction property for every image view. So let's do that by clicking on the attributes inspector again and activating the user interaction enabled checkbox for every single TTT image view that we have in our storyboard. Right. So now we have completed the work with this field. We have created our MPC handler. Now I think it's time that we get started with making connections. We will implement the function for tapping on these fields later. So let's again bring up the assistant editor. Before we can continue, we need to connect our view controller class with the app delegate and with the MPC handler. And we're doing that simply by creating an app delegate property in our view controller class. We'll just call it app delegate. It's of type app delegate, and we will initialize it in the view.load method. And we're doing that by saying app delegate with a lowercase a at the beginning, and calling UI application, shared application, delegate, and we have to cast it to an app delegate in order for this to work. Let me go back to the code view. All right, so there we have our app delegate. There we have our connect with player function. And what we now need to do is we need to check if there is already a session that exists. So what we do is if the app delegate dot MPC handler dot session is not equal to nil. So if a session is existing, let's say a app delegate dot MPC handler dot setup browser. All right, and now let's say app delegate dot MPC handler dot browser dot delegate equals self. So we're using the browser from our MPC handler, but assigning the delegate within this class. So that means that we can also pretty easy say self present view controller, and using the app delegate dot MPC handler dot browser as the view controller which we want to present. Let's animate that, and we won't need a completion block here. And we get an error because we need to implement the proper delegate method for this view controller. And so that we can access this, this delegate, we also need to import the Multipeer Connectivity Framework to this class. And what we can do now is use the MC Browser View Controller delegate. So, so far so good. What we will need to implement is pretty simple actually. We just need the did finish and the was cancelled delegate methods. So let's implement them just at the bottom of our file, and this is going to be a browser view controller did finish and browser view controller was cancelled. And what we are going to do in both cases is we are taking our MPC handler of our app delegate and say browser and this miss view controller animated true with no completion block, and just copy and paste it here. And that's it. But before we can really have a look at what's going on within the when pressing the connect button, we will have to set up our session and our peer, and we have to advertise our device. We're going to do that in our viewDidLoad method here right at the top. And we're going to call our newly created app delegate, the MPC handler, and use the functions that we already created earlier. So we're going to set up the using the setup here with display name, which is going to be the name of the device itself, which we can access by using UI device, then device.current device.name. This gives us the device name, like iPhone Simulator or DevPod in my case. And now let's set up the session, app delegate, MPC handler, setup session. And the last thing we need to do is advertise ourselves by saying advertise self, and we want this to work, so let's say true. Run it in the simulator. Here's the iPod. I press connect. I can see DevPod here already. I press DevPod, and as you can see, I can accept now, and it says connecting, and finally it says connected. So this works pretty nice, and I click done, and well, nothing happens. So let's see what we can do about that. I will just turn off the screen sharing again. We will now work with the notifications that we have created earlier in our MPC handler. There we have the did change state notification, and we also have the did receive data notification. So what we are going to do is we will have to listen for those notifications. We're going to do that in the viewDidLoad method. So let's call the NS notification center, and it's a default center. And let's add an observer first for the observer. which is self. Let's first start with the did change state notification. So we will create a function in a moment, which is called peer changed state with notification. All right. What we're also going to do is now we will copy the name of this notification in order not to make any spelling issues, spelling errors, did change state notification, and we will insert this as a name here. And we don't need an object here. So we are actually listening for this event, MPC did change state notification, which is fired every time, we'll have a look at the handler, every time the state of our session changes. And the state that we get now, because the iPod is connected, is we get the state connected. We could also get disconnected or connecting or whatever. So we use this notification to listen for these events, and now let's also copy did receive data notification in order to create the second notification that we're going to need. So NS notification center, default center, add observer, which is again self, and the selector this time is going to be handle received data with notification. Both times, what I've forgotten here was a colon because we need a parameter later. And let's paste the name of the notification here. And again, we won't need an object here. And since we are already here, I think we have never called our game logic method, which we could actually rename in setup field, which makes a little more sense. So let's call that here just by typing setup field. All right. And now what we need to do is first create this peer changed state with notification function. We're going to do that beneath the connect with player function. And what we do is we're going to create this function first, and it has, of course, one parameter. This parameter is going to be the notification itself that is going to be received by this function, so n is notification, and we won't have a return type here. And now, as I told you earlier, we have created an user info object here within our did change state and did receive data delegate methods, and we have filled this user info object, which is a dictionary, with useful information. So we're going to use this information now. Let's use this information by accessing the user info object of this notification by creating a user info object. Let's use an NS dictionary because it's a little simpler to read, and we'll access the notification.userinfo, and we have to unwrap this. Let's see if this works. Yes. And now let's get the state. So let state equal state, come on, state, and this is going to be user info dot object for key, and now we can just use the key that we have defined earlier, which is state, and convert that to an integer. So, and we're going to use this state now to see if we have successfully paired our two devices using the if statement, and check if state is not equal to MC session state dot connecting, and we'll also convert that to a raw value so that we can compare those two, state and the MC session state. And when it's not connecting, then we can actually assume that it is connected. If you were to publish this app, you should also maybe check if there was if both devices disconnected, and checking all the states. But let's keep it simple here and just inform the user that we have connected. So let's use, because we have a navigation controller here, we can use the navigation item and its title property to tell the user, yes, you have connected. And let's see if this works. The iPod is still running. There is the dev pod. Ooh. So let's accept, connecting, and we're connected, click done. And you see that there is the connected title that we have just assigned. So that is the first step. Now let's continue to work with that, creating another function that listens that is performed when our notifications are fired. So let's also create that beneath the connect with player, and this time beneath the function peer change state with notification. So let's just paste the name handle receive data with notification, and also give this a notification as a parameter, which is an NS notification. So, and now in this function, we are going to fill no logic in yet, because we first need to implement some more logic for the tapping stuff on these game fields. So let me now again select all of them, and let me remove the image so that we get an empty field here, so that you can see when we start the game. We'll see just the empty field. Let's now create the action for our gesture recognizer that we have defined earlier and that we have assigned to every field for the game. So let's just copy the action name that we have defined here and create a function right above the setup field function. Let's also call this field tapped. And what we are going to need here as a parameter is a gesture recognizer. So let's call this parameter recognizer and UI tap gesture recognizer of type, so that we can use it now to create a tapped field object, which will get the recognizer's view, which we will then cast as a TTT image view. And what we can do now is accessing the tapped field and saying set player. And now when I, for example, say X and I run the application, then what we get is we can click on each of these fields and we get the X. So how do we determine which player has just tapped, the X or the circle? So therefore, let's go right to the top of our class and create another property, which will be the current player, which is going to be a string. And we will set this current player, let's say beneath the setup field, to X for the start, and we will then use the current player as the parameter for the set player function that we have created in our TTT image view class. So let's say current player, and that is actually only the first thing that we are going to do within this function. The second thing is going to be that we want the other device to be informed about every tap we make on the game field. To do that, we will create a dictionary that stores the data about the field, the exact position of the field, and also which player just played. And later we can then determine which player's turn it actually is. So let's create a message dictionary, a message that we will send to the other device. And this dictionary has, again, two key value pairs. The first one is the field. And now you will understand why we gave a tag to every image view in our storyboard earlier, because now we can use tapped field.tag to identify every field that has been tapped. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8. And these numbers are corresponding with the index of every field in our outlet collection. All right. Now let's move on by setting the second key value pair, which is player. And this is going to be the current player. And now we need to prepare our data because we cannot send an NSDictionary object or a dictionary object. We only can send NSData objects. That means that we will create a message data object, and we will use the NSJSON serialization class to create a data object with a JSON object. And a dictionary is nothing else but a JSON object, actually. So let's use the message dictionary with NSJSON writing options, let's say pretty printed. And we will skip the error here for simplicity's sake. If you want to do it perfect, then create an error and ask if everything went okay, so that you don't get any crashes, but we will skip that. And now let's actually send the data. Now, in this case, I'd like to use an error object to show you how to work with this specific method, because in this tutorial we are talking about the Multipeer Connectivity Framework. So let's create an error object for the next function we call, and an error object needs to be optional since it must be allowed to be nil. So we define it as variable, we define it as an optional, and let's now call the app delegate again, the MPC handler, and now the session. And now comes the fun part. Now we can say send data, and that's it. And there we have an interesting set of parameters. First, the message data, which we have created. All right, message data. To peers, how do we get the peers? Well, they are stored, again, in our MPC handler of app delegate, in the session and connected peers. And you can see you can connect to many peers at the same time, not just one. So there is an array of peers that we can use here. And here comes an interesting part, MC session send data mode, and there we get a reliable and an unreliable mode. And this is interesting, since the reliable mode explains itself by the framework should guarantee delivery of each message and queuing and transmitting the data as needed and ensuring an ordered delivery. And that's what we actually need, because we cannot deliver one touch before another, then the game would be useless. But if you want to, if you do not have to rely on the order of the transmission, then you could use the unreliable option, which is a little faster. And now let's use the error pointer here, so that we can ask if there was an error. So if error is not equal to nil, so if there was an error, let's just print it so that we can so that we know what went wrong. So error.localized description. Okay, so what we now want to do here, and we can leave it to do here, is we want to check the results. But we're going to do that later. Let's keep that fun part for the end of the tutorial. So now we can tap on fields, and we can also send data, but we have no way on interpreting this data. So what we need to do now is filling our handle received data with notification function with some life. Using a similar concept to what we did here in peer changed state with notification, we will again create a user info object. Again, we will let's this time use the Swift data type so that you can also see how this works. So we are going to use the notification, the user info. This is an optional, so we need to unwrap it. And let's say this is we want to cast this to a dictionary. Very well. And now we can again create a received data object, which is an NSData. And we use the user info now and access the data key that we have defined earlier in the MPC handler. As you remember, here is the data key, which gives us the received data, which is in our case, again, a dictionary, as you can see here. And what are we going? And we will have to cast it to an NS data. So we send a message using every time we tap on a field. So let's first get this message, which is message, and let's this time use the NSJSON serialization the other way around. So we want a JSON object with data, and we use the received data here, and NSJSON reading options. Let's use allow fragments and nil as an error. What we can also use, and what is pretty interesting, is we can get a sender peer ID, which we can then use to get the display name. So let's say sender peer ID, which is sender peer ID, and use the user info again, user info, and get the peer ID as MC peer ID. And what we can do now is we can create a sender display name, and we can now assign sender peer ID dot display name. Well, and that's it. And what we need to do here is we still have to cast that to a dictionary. Let's say in this dictionary. All right. So now we have a message. We have a sender display name. What we can do now is first check if the message. Let's think a little ahead. So what we can do now is we can have a look at the message that we receive. So let me start the game on both iPhone and iPod. And I'm going to use the iPod now, once it's started. All right. So I'm going to send a message by just pressing a button here. And we get an error, and of course we get an error because we have not connected our devices. So let me just do the connection real quick. Let's say done. And let me again tap on, well, let me just tap here. Yeah, as you can see, as soon as I tap on one of these fields, you can see that I get the proper field and I get the player that has just performed this move. So since we have now this message, we can use it and we can get the information out of the dictionary that we need. And the first information that we need is an integer, which is a field, and we will use define this as optional because there could be a situation where we get no value, and this makes it a little easier and safer to handle this data. And let's now use the message and the object for key field so that we get the field, and this is optional. So let's access the integer value, and let's also create the player object, which is a string, also optional. And this is going to be the message and the object for key, since this is an NS dictionary and not just the Swift dictionary, so we can read it a little easier and not having to use the brackets. We're going to access the key player and cast that to a string. All right, and now we can check if field is not equal to nil and if player is not equal to nil. So if there are both values available, then we can say, now this is the interesting part, fields, and now we can use the fields is the outlet collection that we have created earlier here, and we can now use where can we use here? We can use the tag that we have defined, and we can now use the tag which is transferred via the Multipeer Connectivity Framework to the other device to actually set the the field to its correct player symbol. So let's use field. We have to unwrap it though, since we have defined it as an optional. And let's say its player is going to be, well, player. And now let's also say fields. Again, use the field as index. And we'll also say set player to player. All right. And now we can say if player equals to X, without this single quote, if this is the case, if player is equal to X, then the current player is going to be a circle or an O next. And else, current player is going to be an X. All right, and here we have forgotten to unwrap the player, and that's pretty cool actually. And principally now we have a working game, but also here we would have to check for the results. So did someone win? And we still have to implement that kind of launching. So let's again run the application. And let's run it on the iPod, which somehow crashed. Let me just quit everything and relaunch it. So there we go. Running it on the iPod. Now running it on the iPhone 5S. And there we go. Let me connect both devices. I accept. Connecting. We're connected. And I press the center field on my iPod. Now I'm going to press the upper right field, and as you can see, we still when I press the button on the iPod, then I get always the X, and when I press it here, you get the O. So you could also you can really play the game now. But how much fun and how much advantage do we get from an iPhone if we cannot check if someone won, because here the X already won 2 times. So let's implement that check results code by creating a function which is, let's just name it check results. What we need to do is actually pretty simple, but it's some hard typing work. So let me just show and explain it to you. So we have to check every situation when a player is winning. So this could be this row, this row, this row, this one, this one, this one, this one, or this one. Did you count? I think these were 8. Well, I prepared this piece of code already, so that I don't make too many mistakes, because this is really only a routine job and copy and paste work. So let me show you how the final result looks like, and this is just like this. We're using a variable called winner, and we check if the fields 0, 1, 2 are equal to X. 0, 1, 2. If they are equal to X, then the winner is X. And then we have to do the same thing for the field 0, 1, 2, but this time using and checking for the O, if O is the winner. So if here, here, and here is an O, then we can use, then we have to say, well, O is the winner. And we're using the player property that we have assigned to our image view here, so that we can very, very easily check which one is whether. Well, let me put it that way: if this, and this field are occupied with the same player symbol. Okay. Now, what we also need to do is we need to inform the player about whether he is winning or who is actually winning. So let's add a little if statement here at the bottom and say if the winner is not equal to nothing. So if there is a winner, then let's create an alert view, which is a UI alert controller actually, with a title. Let's just say Tic Tac Toe message. The winner is well, the winner. All right. Oh, there's a missing quote, a quotation mark. So alert controller style is alert, and there's not going to be, there's just going to be one action actually, which is alert add action UI alert action. OK style UI alert action style default, and the handler receives an action UI alert action as a parameter. And what we need to do here is actually another to-do case, which is reset the field. All right, and then the only thing missing is we have to present this. View controller. So let's present the alert animated true with no completion block. All right, now we have the possibility to check if someone has won, and let's simulate that. Let me just quit everything and run it on the iPhone. In the simulator, let's also run it on the iPod. Let me bring up Reflector for that. And there we go. Here's the simulator. Here's the iPod. So let me just connect both. Press the dev pod. Here I have to accept. All right. We're connected. So press done. And now let me start on the iPod. So I pressed X. Now let's put a circle here. Let me now put an X here. And circle isn't paying attention, so X is going to win. And nothing happens. Well, why is that the case? Because we have not called the check results function at the proper places. So now we can have a look at our outline view of all our functions here, and there we can see the to-dos here, check result, and here check result. So let's do it here. Replace this comment by just calling check result, and also here check results. And then let's run this again on both iPod and iPhone simulator. So there's the simulator, there is the iPod, and let's start again. And you see both devices are not connected because I have not, I did not connect them. So deactivated, just run it again. And you see where that goes. We have to implement that in a moment. So let's first connect. There is the dev pod. We get the invitation here. Let's say accept. We're connecting. We're connected. I press done. And now I can actually start. And you see how great this is. Both devices are magically somehow connected, and this is a great multiplayer experience, actually. So let me now click here, and let me here, and here, and now let the X win, and there you go. You see, both devices see that X is actually the winner. All right, now we want to play again, actually, but it's not working. There's nothing that could do that. And what we have to do now is we have to implement a proper function for this. And we will let's first create a function to reset the field. Say it's called reset field. And we will do something pretty similar to what we did here, just using a for loop for index in 0 to fields.count -1. And what we do is we will say that fields index dot image is going to be nil. What we also want to say is fields index activated is going to be false, and the player of one field index player is going to be empty string. And what we also want to do is reset the current player to X. All right, so much for that. And now what we also need to do is create a IB action for our last button, which has nothing to do since we created it. So let's change that by, let's bring it beneath reset field and call it new game connect. Go back to the code window. And what we want to do actually is we want to display a message to the other player if we start a new game. So let's first call our reset field function, because every time we start a new game, we want to reset the field. And let's also, again, like we did earlier with when we touched or we tapped on a field, let's again create a message dictionary and assign a key value pair, only one, which is called string, with the message new message, with the message new game, so that we can determine whether in our handle received data with notification function, whether we just received the position and the player of one move in the game, or if we received the information that a new game has to start. So we have created the message. So now let's create a message data object again. We're using NSJSON serialization and data with object and message dictionary, NSJSON writing options, pretty printed, no error. So here this time, again, let's create an error for the next function, which is appdelegate.mpchandler.session. And now again, the send data function is what we are going to call, since we now want again to send data from one device to another, and we're sending the message data to the peers, which are stored in appdelegate, MPC handler, the session, and all the connected peers. Again, the mode is going to be reliable, since we want all the transmissions happen in the exact order that they were placed in. And now let's assign the error object and say if there was an error. So if the error object is not equal to nil, then let's print the error using the localized description of the error. And if there was no if there was no error, then everything is fine. Don't need to do anything here. But what we need to do is we need to get up to our handle received data with notification function and check. Well, not here. Let's check this here. We check if actually not here as well. We check if the message that we received is new game. So if message object for key string is equal, let's use is equal to string new game. If this is true, then what are we going to do? Then we create an alert view, alert, equals UI alert controller with title Tic Tac Toe, and the message is going to be the sender display name. So the guy who started the session has started a new game. All right. And well, all we need to do now is add, let's finish this here, alert controller style, alert, and let's finish it by add one action, which is just the OK button. Alert action, OK. It's going to be the default style. alert, action style default, no handler required here. And now let's present this view controller, alert, true, nil, so true here. Yeah, and that's actually it. And what we need to do again is reset the game field as soon as we did that. Since a new game was started, we reset the field, and else now we have to move all of that stuff here into this else block, since we only want to do that if the message that we received is not new game. So as you can see, we have a data object here. We have a message data object here, which is a dictionary. It contains the string new game. We check if there is this string, if it is equal to new game, then we want to start a new game. We will reset the field. And else, if that is not the case, so when we have tabbed a field, then we want to check if the data is correct. So if there is data for the field and there is data for the player, then we can actually set on both devices the correct field with the correct player. And at every move, we check the results to see if someone has won. So, and there is one to do left, I think. When someone won, we also want to reset the field. And I think, well, it looks pretty good, except that I have to put a self in front of that since we're in a closure. So let me run the game on both devices. First, bring up the reflector. All right, it's already running. Started on the dev pod. Started on the simulator. All right, DevPod is taking a moment. Well, it's an iPod 5th generation, but has the processor of an iPhone 4, I think. Or is it a 4S? Well, it's slow. Let me run that again. All right, there it is. Well, where is it here? All right. So now we have both devices here. I connect to the DevPod. I get the message, yes, I want to accept, let's play a game. We're connected, it's displayed here. Here we're also connected, so let's start with the game. Okay, I'm playing. But DevPod thinks, well, I don't think that I'm going to win, so let's start a new game. All right, and we see DevPod has started a new game. Okay, so let's start again. I start here, and boom, and here. And oh no, DevPod is going to win. Oh no. Someone has to win this time, so let's click here. And you see Tic Tac Toe, the winner is X, and also we get the same message on the iPod. And when I click OK, when I press OK, then you see the game is reset. So this was our tutorial about the Multipeer Connectivity Framework. We have created a cool multiplayer game, Tic Tac Toe. We have used JSON serialization. We have used this great framework, Multipeer Connectivity, the Multipeer Connectivity Framework. And there is still something missing, and I think it's a good training if you try that part for yourself, and figure out how to actually make it possible that while one player is playing or has to play, the other is not allowed to make a move, because now I have clicked on the in the simulator, but now I shouldn't be. I can click again. But I shouldn't be able to click again until the other player, the circle, has made its move. So it could be interesting to figure out how this works. And if you want, just post your solution below and have fun creating this nice little game.